Yes, it's Uncle Jegs, and this video is all about the making salts required practical. There's a bit of theory that we need to cover to be able to fully understand this practical, but it ain't that deep. The first thing we're gonna do is look at neutralisation reactions. I'll also go through how to name some of your salts. Then we're looking at 2 of the 4 separation techniques that you need to know about. Then we'll go through the required practical, and then finally we'll look at a possible question that you could get that bare people get confused with. As always, check the description for the worksheet for today's video and also the answers to the previous video's worksheet. Alright, let's keep that thing. Salts are one of the products formed when acids and bases react together. A quick side note on some important definitions. pH is a number that tells us how acidic or alkaline a substance is. Acids are solutions with a pH lower than 7. Alkalis are solutions with a pH higher than 7, 7 being neutral. The difference between an alkali and a base is that bases are insoluble, so they do not tend to dissolve well to form solutions. The general definition for a base is a metal oxide, hydroxide, or carbonate that reacts with an acid. All alkalis are bases, but only the soluble bases are alkalis. Alright, look at this Venn diagram just to clarify that. Before I move on to the reactions, let's look at the 3 different types of acids that you need to be aware of. You have to memorize these things. So first we've got HCl, which is hydrochloric acid. Then we have HNO3. The 3 is subscript, so that goes at the bottom. That is nitric acid. And then we've got H2SO4, and that one there is sulfuric acid. You also need to know the salts that each of these acids make. Notice that each of these acids have a hydrogen on them, at least one hydrogen. These hydrogens are special because they can break away from the structure. They can dissociate. Not all substances with hydrogens can do this though, it's only acids that can do this. The more hydrogen ions there are in a solution, the more acidic it is. That is where we get the H from pH from. That's where we think we get it from. We think it means the power of hydrogen, but no one really knows because it wasn't really clarified, and this was made like 100 years ago or something like that. I'll speak about strong acids and strong alkalis and weak acids and weak alkalis in a future video. A salt is a substance in which the hydrogen of an acid is replaced with a metal ion. When an acid and alkali react, we get salt and water. Salts have 2 names. Think of it like a first name and a surname. Let's first look at a reaction between a metal hydroxide and an acid to show this. Table salt is sodium chloride. Notice that the metal part of the name of the salt comes first. We call it sodium, which is the metal, then chloride. The surname of the salt comes from the acid. You should have already guessed which acid makes sodium chloride now. That's hydrochloric acid. Nitric acid makes a nitrate, and sulfuric acid makes a sulphate. When an acid reacts with a metal oxide, it forms salt and water as well. Look at this specific example. My acid here is nitric acid, and my metal oxide is magnesium oxide. So you should already know the salt that should be made. That should be magnesium. The metal part of the name goes first. Magnesium nitrate, because we're using nitric acid. Don't worry about the brackets for now. I'll do a video on all of that in a future video, yeah. It's a little bit different with the metal carbonates though. They make salt and water as well, but they also get bubbly. They release carbon dioxide. Here I'm reacting magnesium carbonate with sulfuric acid. What do you think will be formed? Get into the habit of underlining the chemicals that the question is giving you and the salt that it's asking you to make, so you can work out if there was a mistake made in the method that they show you. You need 2 of your 4 separation techniques for this required practical: filtration and crystallization. Filtration is used to separate insoluble solids from a solution. You use a filter paper and funnel and allow gravity to pull your solution into your conical flask. When a substance dissolves in water, the water molecules surround the individual particles and interact with them. This moves the particles away from their crystal lattice structure. This is why it looks like the solid is disappearing. It's because it's broken down into pieces too small for you to see. Filter paper is made up of tiny gaps that are big enough to allow the dissolved substances to move through, but too small to allow the insoluble solids to move through. The solid at the top is called your residue. The liquid that makes it through your filter paper is called your filtrate. Crystallization is almost the opposite of dissolving. To dissolve something, the water particles need to surround your individual particles and move them apart from their crystal lattice structure. For us to regain that crystal structure, crystallization, we need to get rid of the water somehow. And the simplest method of getting rid of water is just heating it up. That's because water has a lower boiling point than most of the salts. I think all of the salts have a higher boiling point than water. However, there's a bit of a catch-22 here. That is because the quicker you crystallize your salt, the smaller your crystals. Therefore, if you want large crystals, you need to be very careful and heat your solution gently. Also, only boil away about half of the water and then leave the rest to evaporate overnight. That should ensure that you get large crystals. Now onto the required practical itself. So we have to prepare a salt from an insoluble base and an acid. Since we're trying to make copper sulphate, we need a copper base and also sulfuric acid. First thing we do is that we measure out around 40 centimeters cubed of sulfuric acid using a measuring cylinder, of course, and add it to a beaker. Then we heat the acid gently until it's almost boiling. Please don't boil your acid, that's dangerous. Then we add a small amount of our copper 2 oxide and stir it. We keep adding this until it doesn't react anymore, so we have it in excess. And the way you can tell this is that when you were adding your copper oxide before, it was going blue, it was turning into a blue solution. But then when it's in excess, you just have the black solid just sitting in the solution. Now leave your solution to cool down, and it's time to filter your solution. We filter it to get rid of that excess copper 2 oxide, so that becomes our residue on the top. So the filtrate that comes through is our copper sulphate solution. But we want dry crystals of copper sulphate. These next steps are how you collect your pure dry copper sulphate crystals from your solution. One thing that the examiners might do is that they will ask you, how do you collect pure copper sulphate crystals from copper sulphate solution? If they ask you that, you do not need to talk about any of those other steps I just mentioned. You talk about these steps here, yeah? So the first thing we do is that we heat the solution gently. We stir the solution as well with a stirring rod. As the water evaporates, the solution becomes saturated, which just means that there isn't enough water to keep the salt dissolved. Then crystallization will occur. That's when your crystal starts forming because the water is evaporating away, allowing the particles of your salt to recrystallize. Then you dry your salt crystals with tissue. This is to remove any unreacted acid on top of them. Now, a big question you may get is something like this. Remember to highlight the important parts of your questions like this, yeah? A student plans a method to prepare pure crystals of copper sulphate. The student's method is, number 1, add 1 spatula of calcium carbonate to dilute hydrochloric acid in a beaker. Number 2, when the fizzing stops, heat the solution with a Bunsen burner until all of the liquid is gone. The method contains several errors and does not produce copper sulphate crystals. Explain the improvements the students should make to the method so that pure crystals of copper sulphate are produced. First thing you should do is look at the substance you're trying to make, copper sulphate. That means that we need to use a copper base You can pick any of the bases, but might as well stick to oxide because that's what you use in your required practical anyway. So use copper oxide. Since it's a sulphate that we want, we should use sulfuric acid. Also notice that they did not separate the excess copper oxide via filtration and didn't allow the crystals to form via slow evaporation. Since this is an explanation question, we need to use the word because in our answer. So look at my answer here. My first point, use copper oxide instead of copper carbonate because a calcium salt will be formed. The next step, use sulfuric acid instead of hydrochloric acid because a chloride will be formed. The next one, add the copper oxide until it is in excess. The next, filter to remove the excess copper oxide. Then the next, gently heat to evaporate half of the water. And then finally, leave to cool to allow crystallization to occur. Now look at the mark scheme. To get the 5 and 6 marks, you need to be logical and clear and give reasons for what you do. Get into the habit of writing like this, okay? You can even write in bullet points. There we go. The making salts practical. Download today's worksheet and the answers to the previous worksheet from the description below. Like if you like, sub and click the notification to get alerted every time when I drop something, and yeah, in a bit.